This video is going to cover the 11-9 warm-up and then a quick review for your Chapter 11 test, which is Wednesday. Alright, so this, if you'll actually pause the video and allow the students to make sure there's enough time for them to work on the warm-up, and then unpause it when you're ready to go over the answers. Okay, so number 1 says, 2 triangular prisms are similar with surface areas of 9 feet and 25 feet. What's the scale factor of the prisms? So if we remember from Friday, we talked about scale factor being A to B. Areas would be A squared to B squared, and volumes would be A cubed to B cubed. So because these are areas, this is the A squared to B squared. So if I wanted to figure out what the scale factor would be, I can simply square root each of these numbers, and I'd get scale factors 3 to 5. Okay, 2 says 2 spheres have volumes of 125 pi meters cubed and 216 pi meters cubed. What's the scale factor of the spheres, and what's the ratio of the surface areas? So now we're working with volumes. So A cubed over B cubed would give you 125 pi over 216 pi. So if I wanted to figure out, I can just simply cube root these terms. So I'd get the cube root of, and 125 is 5, and 25, which is 5 and 5. So I would get the cube root of pi, because I don't know what that is, times 5, and then the cube root of pi, and 216 would be 3 and 72. You can do 2 and 36, 2 and 18, 2 and 9, 3 and 3. So if I count the digits, there's 1, 2, 3 3s, so a 3 can come to the outside. And there's 1, 2, 3 2s, and a 2 can come to the outside. So if I didn't know that the cube root of 216 was 6, I can figure it out that way. And then because there's a cube root of pi over a cube root of pi, these can cancel out, and I get simply that the ratio, or the scale factor, would be 5 to 6. And then the second part of this says, what's the ratio of the surface areas? So now I can take that scale factor, that 5 to 6, and square each of these terms to get the areas, which would be 25 to 36. So 5 to 6 would be the ratio of the scale factor, and 25 to 36 the ratio of the surface areas. Okay, number 3 says the volumes of 2 similar square pyramids are 8 feet cubed and 27 feet cubed. What's the ratio of the surface area of the smaller pyramid to the larger? So smaller to larger gives me the order. This is volume 8 to 27 would be my A cubed to B cubed. I can work backwards to get to the scale factor. So if I cube root 8 and I cube root 27, I end up with 2 and 3. That's the scale factor. This is the surface area. So then I can take that and square it, and I'd get 4 to 9. And that would be the ratio of the surface area. And this last one says the 2 solids are similar. Find the surface area and volume of solid 2. So what's given on both of them is the radius. So if I want to establish the surface, or the scale factor, I would do 2.5 to 5, which is 1/2. That's my scale factor. And then I can use that to find the missing segment, which is the height on this cone here. So if this is 6 and this is 1 to 2, then I would double this to get the height here being 12. So now I want to find the surface area and the volume of that solid, which is going to be I'm going to find the surface area of the hemisphere and add to it the surface area, well actually just the lateral area, because I don't want the base, the lateral area of the cone. So the hemisphere would be 4 pi 5 squared, and I'm going to take 1/2 of that because that's the actual whole sphere. So 1/2 of 4 is 2, times pi times 25, this is 50 pi. And then the lateral area of the cone, which is going to be all the way around, is pi RL. So I've got the radius, which is 5. What I don't have is L, which is my slant height. But this is a triple. It's a 5, 12, 13, which makes that 65 pi. Add those together, 115 pi centimeters squared. That's the surface area of the second solid. And then for the volume, I'll find the volume of the hemisphere and add to it the volume of the cone. And I don't have to adjust that in any way because it's still all the way full. So hemisphere would be 1/2 4/3 pi 5 cubed. And the volume of a cone would be pi r squared. And r, I can plug in pi r 5 squared times the height, which is 12. So this is 1/2, well, I can simplify this, 1/2 and 4, this goes 2 times, so 2/3 pi times 125. And 3 doesn't go into 125, so I'd multiply that out, I get 250 pi over 3. That's the volume of the hemisphere. And then the volume of the cone, pi times 25 times 12, which is 300 pi. And then I want to add these two together, so I give them a like denominator. If this is over 1, to make it over 3, this would be 900 pi. Add this to this, I get 1150 pi over 3, and it would be centimeters cubed. All right, so here's a quick review for what's going to be covered on the test. So it's chapter 11.6 through 11.9, and then it's got all the surface areas that we added. So the surface areas came from the prisms, so you need to know total area and volume of a prism and of a pyramid and of a cylinder and of a cone. And actually I'll add in here lateral area. Some of them you'll need to know, some of them will go straight to total area, but we'll add it in here anyways. Lateral area, total area, and volume. These should all be on the little cheat sheet that we made, but every time you write it, it helps you remember it. So it's a good idea to rewrite these out one final time. All right, so I'm going to start in the prism. The prism lateral area is perimeter of the base times the height. The total area, there's 2 bases on a prism, so it's 2b plus pH, or 2b plus the lateral area. And then the volume is the base area times the height. And then within here, we had a cube, which the volume was side cubed, and a rectangular prism, where the volume would be length times width times height. So kind of little shortcuts for those. I'm actually going to go into the cylinder. Since the cylinder is basically a prism with a circular base, these should be easy to derive from the ones that are the prisms. So lateral area, because it's perimeter times height, and the cylinder's base would be a circle, the perimeter of a circle, which is 2 pi r, that's your circumference, would get multiplied by the height. Total area, again, there's 2 bases on a cylinder, but these bases are circles, so it'd be 2 pi r squared plus 2 pi r h, or 2 pi r squared plus the lateral area. And then the volume is base area times height. The base is a circle, so pi r squared times the height. Okay, so now let's come over to the pyramid. So the pyramid, which could be something like this would be a square pyramid. The lateral area is 1/2 the perimeter times the slant height. So if we remember, slant height runs along the side of the pyramid. The total area, there's only one base this time, so it's B for base area plus 1/2 the perimeter times the slant height, or base area plus the lateral area. And the volume, the pyramid, and the cone both have the 1/3 starting out. So this would be 1/3 the base area times the height. So for the pyramid, we use the regular height for volume. So quick refresher on those. When we're making these square pyramids, because you might need the height, you might need the slant height depending on what it is. This is 1/2 its base here, 1/2 the base edge. This would be your height, and this would be your slant height. Those three things form the right triangle that's inside that pyramid. Okay, and then the last one, which is a cone. And a cone is just a pyramid with a circular base. So lateral area, which would be 1/2 perimeter times the slant height, is 1/2 perimeter is 2 pi r. So the 1/2 and the 2 cancel out. So this is just pi RL. Total area, there's a base of a circle, so it's pi r squared plus pi RL, or pi r squared plus the lateral area. And then the volume, the 1/3 starts it again. The base area, the base is now a circle, pi r squared times the height. So in a cone, the height, the radius, and the slant height make that right triangle. Okay, so that kind of is 11.6 and 11.7 mixed in with the surface areas that we added in from the other book. $11.8 was all the spheres. So we think of a sphere like a globe or a basketball with just the radius measurement, or sometimes you'll get the diameter. There's no such thing as lateral area here because it's one full area. So total area of a sphere is 4 pi r squared, and the volume is 4/3 pi r cubed. And then if we did a hemisphere, we would do 1/2 each of these. So it would be half that 1/2 the 4 pi r squared, which is 2 pi r squared, or it'd be 1/2 4/3 pi r cubed, which would be 2/3 pi r cubed. So you don't really need to memorize these. As long as you can take these and multiply them by 1/2, you would be able to get the hemisphere measurements. Then the last section was 11.9, and this was your similar solids. So two solids that are similar have to be the same shape. You can't compare like a sphere to a cylinder or a prism to a pyramid. They'd have to be to each other. And the ratio of the sides, or a linear length, which could be the radius, the side length, the height, the slant height, any of that stuff, it would be A to B. This would be the same for the perimeters. Ratio of the perimeters would also be A to B. The ratio of the areas would be A squared to B squared. And the last one is the ratio of the volumes, which would be A cubed to B cubed. So in these kinds of questions, you'll see kind of like where you would get the side lengths, and you'd have to find the ratio by squaring them. So if I said the ratio of two perimeters or two side lengths would be 2 to 3, then the areas would be 4 to 9, and the volumes would be 8 to 27. Or it could work the other way around. Like, let's say they give you the ratio of the volumes and they want the side lengths. You would have to work your way backwards. So you'd have to find the cube root of each of those numbers. Okay, so if you'll use the remaining time in class to work on the chapter review assignment that's on Canvas, should also be on your to-do list. It's due tomorrow. Make sure that you submit these notes, warm up, so the warm up and the notes should be submitted as one file before you leave class today. Have a great day.